Hey everybody, welcome to this video. Today we're going to talk about two-step equations. This is a big part of our class. This is a big part of algebra next year. And so I really wanted to focus on this today. And I really would emphasize that this is a topic you need to feel comfortable with by the time you're done with 8th grade. Because if you're not feeling too confident about these questions, it will really make Algebra 1 next year at the beginning of the year a little more challenging. This is one of the most important things that we do in the entire year. So hopefully this video will help you get more comfortable with two-step equations. Now they're called two-step equations because it takes 2 steps to solve them, right? There are 2 operations. When I say operations, I mean adding, subtracting, multiplying, or dividing. There are 2 things happening to the variable in the question. For example, a two-step equation may look like this, and I'm just going to make one up here. This is not an official question by any means that we're going to answer, but there are 2 operations happening to the letter M in my equation, right? Everyone can see that the letter M is being added with 6. That doesn't take much to see, but there's also multiplying right here, right? -4 is being multiplied by the letter M. And so in order to solve these, what you want to do is you want to work backwards. You want to kind of unravel what is happening to the variable in the question, right? My eyes always go directly to the variable, whether it's on the left side of the problem, whether it's on the right side of the problem. I'm always searching for that variable because I need to undo what is happening to the variable, which operations are happening. And so you can see here I have kind of some steps laid out for us. Step 1, we will always undo the adding and subtracting part first. Undo the adding or subtracting part first. So in this one, instead of adding 6, we can undo the inverse of adding 6 with subtracting 6. We would do subtracting 6 on both sides of the equal sign. And then once you do that, step 2 is to always undo the multiplying or dividing. And in this case, we have multiplying right here. And so we would undo this multiplying by -4 with dividing by -4 at the end. And that is the way I will do 99% of these questions. 99% of the time, you will always go in this order. Step 1, undo adding and subtracting. Step 2, undo multiplying and dividing. Now you're curious, okay there, buddy, what's the 1% of the time where you don't go in this order? And I will show you that at the end of this video. And there's a special type of question when I do that, but I'll be perfectly honest with you, it doesn't happen very often. So 99% of the time, we're going to undo the adding or subtracting first. For example, in this question, letter A, you can see that we have adding 2. The letter X is being added with the 2. The letter X is also being multiplied with the number 3. So we have 2 operations happening to the letter X. We're going to have to undo these. We're going to work backwards. You know, for those of you who learned the PEMDAS thing, right, in 5th grade, 6th grade, 7th grade, whenever they first learned that, you are used to doing parentheses and then exponents and then multiply and divide and then add and subtract in this order, right? Now, since we're working backwards, since we are solving, they've already got the problem written and we've got to work backwards to find the answer to what X is, we're actually going to work this in the opposite order. I'm actually going to start right here with the adding and subtracting, and then I'll move up to multiplying and dividing as I go. So we're working backwards here. Instead of adding 2, I want to do the inverse, the opposite of adding 2, which is subtracting 2. And look how you do this. You do it once on the left-hand side of the equal sign. You need to do it also on the right-hand side of the equal sign. In our textbook, they call this the subtraction property of equality. All that means is if you do the same thing, subtract the same number on both sides of the equal sign, you're still okay. Your statement is still a true statement. So over here, 20 minus 2, we know that's 18. Use your fingers, use your toes, use your calculator. Here, 2 minus 2 equals 0. Positive 2 and negative 2 are opposites. It has to equal 0 for you to cross it out right here. If it doesn't equal 0, you've made a mistake, and you need to go back and look at what you did wrong. But that equals 0, so I'm going to just cross it out. Then I'm just going to drop this down. 3 times something equals 18. Now, a lot of you know that in your head. But if for some reason you didn't know that in your head, step 2, the letter X is being multiplied. Instead of multiplying by 3, I can do dividing by 3. That is the inverse of multiplying by 3. I'm going to undo multiplying with dividing. Right here, 3 over 3 equals 1. And that is good because 1x is just the same thing as x. And then this is where my answer comes from, 18 divided by 3, which we all know is 6, either in your head or with a calculator. Okay? You can see we had the 2 steps. In step 1, we're doing the adding or subtracting on both sides. Here we did subtracting on both sides. And then step 2, we're going to do multiplying or dividing. It's usually dividing, and here we did dividing by 3 on both sides. Okay, now let's do a different example. This one is a little more tricky. Do you see on this one, the letter N is in the middle of the question instead of being at the beginning? So this is a little bit rude of them, but I wanted to put it in here because people who write math questions sometimes do things like this. The letter N is being multiplied with 2. I like to put the dot in there. It's not showing up very well, but I like to put the dot in there. You don't have to do that if you don't want to, but I like to. I can see that it's being multiplied by 2. I can also see it's being added with the 5. Remember, undo the adding and subtracting part first. So instead of adding 5, I want to do subtracting 5. Subtracting 5. Whatever I do on one side of the equal sign, I need to go way over here and do it on the right side of the equal sign. I don't want to put it right here, right? This wouldn't make sense. Not only are both of these on the left-hand side of the problem, but how do I subtract an n with a 5? Answer, you don't. It's not possible. And so over here, 5 minus 5, does that equal 0? Yes, it does. And so if it equals 0, I can cross it out. Over here, I'm left with 2 times n, just hanging out. I'm not messing with that right now. I always say to save that letter n for the very end. And here, negative 1 minus 5, that's a very difficult one for kids in 8th grade to do in their head. Use your calculator if you need help, but that's actually negative 6. And now, step 1 is complete. I did subtracting on both sides. Now, step 2, I have multiplying right here. The n is still being multiplied by 2, so I can undo multiplying 2 with dividing 2. Right here, 2 over 2 equals 1. So 1n is just the same thing as n. Here's my answer, negative 6 divided by 2. Use the calculator if you're not that confident. Most people know this one, though. Negative 6 divided by 2 is negative 3. Boom, we did it. Okay, now, every once in a while, the book will be kind of rude to you. Let me show you a couple of rude examples. This one isn't super rude, but it has a fraction in it. Don't let the fraction throw you off. You can still do this one with the same concepts that we have been doing. I still have multiplying going on. The letter A is being multiplied by 1/2. The letter A is being added with 9. Remember our process. Step 1, undo the adding and subtracting. So instead of adding 9, I want to do the opposite or the inverse of adding 9, which is subtracting 9. Now, if I do it on one side of the equal sign, I better go way over there on the left-hand side and put it over there. Negative 1 minus 9. That's very difficult for 8th graders, at least in my school, to do in their head. Probably all over. This is a really tricky one. A lot of people think 8. They think a negative 8. They don't really know. It's actually negative 10. And then over here, 1/2 times A is still there. Here, 9 minus 9 is 0. If it equals 0, you get to cross it out. And now I have this statement. It's kind of written backwards because the A is way over here on the right-hand side of the equal sign instead of being on the left where it usually is, but it's all right. I can deal with it. What's happening right now with the letter A? It's being multiplied by 1/2. And this is a throwback to the first lesson in the chapter. The opposite of multiplying 1/2 is dividing 1/2. Now, how often in your life did you write it like this? A fraction underneath another fraction? That doesn't happen very often, does it? I mean, I can't cross this out because anything divided by itself equals 1. But we really don't write dividing like this, do we? You usually wrote dividing like this, going across horizontally. And so we can put this over 1 to make it look like a fraction. But then hold up, did we actually divide fractions? No, we didn't. In 5th grade, 6th grade, whatever grade that is, we would always, instead of dividing, we would do keep, change, flip, whatever you wanted to use for your acronym. We would multiply by the reciprocal. So what this would really look like is keep this the same, negative 10 over 1. I'm running out of space. Change the dividing to multiplying, and then flip, use the inverse, the multiplicative inverse, the reciprocal, flip 1 over 2 to be 2 over 1. And now you can just work it out. Negative 2 times 10 is negative 20. 1 over 1 is technically 20 over 1, but anything over 1 really doesn't need to have over 1 on it. It's really the same thing as negative 20. A equals negative 20. Now, could you just put negative 20 and would your teacher be okay with it? Probably. Do you have to put A equals negative 20? Not necessarily, but you can. Okay, so if you're not the best at the fraction ones, pause that video, rewind it, watch that one as many times as you need to. Here is a really, really mean one. And this one fools almost every single person that sees it the very first time, so don't feel embarrassed if you mess this one up. We have multiplying. And a lot of people think, okay, we have subtracting going on, right? I mean, that's obviously a subtracting sign. And so what they would say is, okay, the opposite of subtracting is adding. And so a lot of people think, okay, I'm going to go out here because this is where I've been normally doing stuff. And they think, all right, I'm going to do, instead of minus, because this is minus, I want to do plus 10. And so a lot of kids write this. Now, I want to hold up real fast because hold your horses. Wait a second. Does this equal 0? It does not. Look what this equals. 10 plus 10 equals 20. Can I cross this out like I've been doing on all the other questions if it equals 20? No, I can't. The only reason I get to cross it out is because it equals 0. So I really don't want to do plus 10. If I'm being honest with you, this subtracting goes kind of with the 2/3. This is a positive 10, right? They didn't put a plus sign on it, but this is positive 10. The way that I can undo this is not with adding. I need to do 10 minus 10 and minus 10 to cancel it out, right? That's going to undo my number over here. And so this one fools almost every single person who sees it for the first time. Look, 10 minus 10 is 0. That's why I get to cross it out. I don't just cross it out for fun. I cross it out because it equals 0. Okay, this subtracting sign just kind of magically transforms into a negative sign. Don't let that throw you off. Over here, 52 minus 10 is 42. I know that in my head. Hopefully you do too. Use a calculator if you don't. And now this statement looks exactly like the last question. My letter P is being multiplied by negative 2/3. The inverse of multiplying negative 2/3 is dividing negative 2/3. Now, dividing negative 2/3 looks a little weird because 42 divided by negative 2/3 is not how I'm used to writing it. I'm used to writing that like this, 42 over 1, if you need to make it a fraction, divided by negative 2/3, right? This is the same thing as this, isn't it? Just a different way to write. Division is just going side to side using this symbol rather than going up and down and using the fraction bar. And so if you've been in our school for a while, you maybe learned this keep, change, flip acronym. Really all it means is dividing by a fraction is the same thing as multiplying by the reciprocal. And so we're going to flip this one upside down. The reciprocal is negative 3 over 2. It doesn't really matter where the negative sign is. Some kids get freaked out, and they're like, oh, wait, you put a negative up here, and now you shouldn't the negative go down with the 2? It can. It doesn't really matter, if I'm being honest with you. Some people would reduce it right now. If you're really good at mental math, you might say, hey, wait, 2 goes into 42 a certain amount of times, but not everyone can do that in their head. And so some people might just do 42 times negative 3, which is, oh, geez, this is going to be a hard one for me. Negative 126. This marker is not wanting to write very well today. Negative 126, and then 1 times 2 is 2. I'm going to get rid of this blue, and it's not doing the job for us. And so what we can do instead, we have negative 126 over 2. We can just type that in a calculator or divide that in your head. What's half of negative 126? Should be negative 63, and purple isn't much better than blue. Negative 63 is what we're looking for on that one, okay? P equals negative 63. Here you go, yellow. Nice and bright for you. P equals negative 63. Okie doke. I just have a couple more. So far at the end we've been doing dividing. I wanted to show you a couple that will have multiplying at the end, and that is this one, or actually these two. On letter E, my letter N all of a sudden is being divided by negative 3, and it's being subtracted with 2. So I'm going to undo the adding and subtracting first. Don't let this throw you off. We're still following the same steps. Step 1, undo adding and subtracting. So instead of subtracting 2, we want to do adding 2. Okay. Right here, negative 2 and positive 2 equals 0. They cancel out. Those are opposites. Negative 18 plus 2, use your calculator if you're not that confident on that. That is negative 16. And then this, I'm just going to drop it down. Now, what is happening to the letter N? The letter N is being divided by negative 3. A fraction is a way of showing division. How do I undo dividing? With multiplying. Here's how I was taught to show my work back in the olden days. Some kids may want to put this over 1, but you really don't have to, right? 3 over 3, you've maybe seen that before, how to cancel that out. You can just get N over 1, which is the same thing as N. And then here's your answer, negative 6 times negative 3. When you're multiplying two negatives, make a positive. And then I think I know 16 times 3 is 48. If you don't know that, use your calculator because I'm not 100% sure, but I'm pretty confident that is right. Okay, let's do one more of those. Here's a mean one. This is a mean one because look, the W is in the middle instead of having it at the front like on this last one we had the N at the very beginning. Now we've got it stuck in the middle, so don't get fooled. A lot of you are going to look at this and you're going to say, okay, I have subtracting and I have dividing. And so some people might say, wait, okay, to undo the subtracting, I'm going to do adding. Hold your horses. Is this going to work? Look at what I have right here. Does this equal 0? Nope. The 15 is not negative. The 15 is positive. This subtracting goes with the W. So I don't want to do plus 15. I need to do minus 15 to make it equal 0. And so over here, it also needs to be minus 15. This one was a tricky one. 15 minus 15 is 0. I have negative W over 4. And then right here, 28 minus 15, I think I can subtract that. That equals 13. And look what we have. Don't let the negative up here really bother you. This is the same thing as saying it's being divided by negative 4. Okay, the negative can be here, the negative can be down here, the negative can be out in front of the fraction. It doesn't really matter. This is the same thing as saying the W is being divided by negative 4. So how do I undo dividing negative 4? The opposite or the inverse of dividing negative 4 is to multiply by negative 4. Multiply by negative 4. Over here, the 4 and the 4 cancel out. Whoops, and it also takes out the negative sign. And just, we're waiting for our final answer. W equals 13 times negative 4. Oh, geez, that's a hard one. I think that's 52, negative 52, because the signs are different. But if your calculator says something different, you can tell me in the comments that I messed it up. Okay, those are about the hardest questions we can get. That will get you 99% of the questions where I said this. Step 1, undo the multiplying, or undo the adding and subtracting. Step 2, undo the multiplying and dividing. Now, I said that works 99% of the time. Here is the 1% of the time where it doesn't work. Look at these. Whoa, boy. Do you see how these are different? Obviously, right? We have a giant fraction. The whole thing is a fraction. It's not like the last one, where just this was a fraction and this was its own little subtracting part. Or right here, just this was a fraction, but this was not. The whole thing is a fraction. The whole left-hand side, or it could be the whole right-hand side. But on these, it's the whole left-hand side that is a fraction. When this is the situation, now my steps aren't going to help me. I need to do these actually backwards. I'm going to flip step 1 and step 2. I mean, how would I do plus 4? If you're thinking, oh, Mr. Reed said I have to do the adding and subtracting first. Instead of minus 4, I have to do plus 4. Where would you even write it? You can't even write it right here to cancel it out. There's no space. And so don't do the adding and subtracting first when it looks like this. When it looks like this, I want to get rid of this ugly fraction. Instead of dividing by 5, I want to do the inverse of dividing 5, which is multiplying 5. Multiplying 5. And over here, the 5s will cancel out. And the only thing you'll have left is a minus 4. Whatever's on the numerator of the fraction will just be what you're left with. On this side, 12 times 5, calculator or my head might be able to get that one, is 60. And now, you might know this one as well, but the letter A is being subtracted, so I can do adding. Instead of minus, do plus. So you see how the steps are reversed on this one? This is the only time that I will do the multiplying and dividing first. The only time I do multiplying and dividing first is when the entire thing is a fraction. Otherwise, I always do the adding and subtracting first. Let's look at one more of those. The entire left-hand side is a fraction. That is not good. I cannot do the subtract. I can't do subtracting 3. There's no room to even put it down here. I'm going to get rid of this. Instead of dividing by 8, I want to undo the dividing with multiplying by 8. Multiplying by 8. Over here, 8 and 8. 8 over 8 knocks itself out because 8 over 8 equals 1. And I'm just left with n plus 3. This 1 doesn't really matter because anything over 1 is the same. Right here, negative 4 times 8 is negative 32. And now I'm going to do the adding and subtracting last on this one. Instead of adding 3, the letter N, I don't want to have adding 3. I need to do subtracting 3 to undo it. And I get negative 32 minus 3. That's kind of a difficult one. Use your calculator. Sorry about the bell right there. And you get negative 35 if you do that on a calculator, if you do that in your head correctly. So those are the only situations where I flip my steps, where I do the adding and subtracting last, and I do the multiplying and dividing first. The only time you do that is when the whole left-hand side or the whole right-hand side is a fraction, like the variable, it's one giant fraction where the variable is. That's the only time I'll do that. Okay, thank you so much for watching this video. Feel free to pause it, rewind it, go back, watch any questions you're still confused on, fast forward it to ones that you're really needing help with. If you understand one, you don't have to watch it all the way through. I'm going to post some questions in our Google Classroom on the McGraw-Hill site, some instructions on how to get there. Please ask me or email me if you have problems, and I'm also going to post Ms. Boseller's video that she put in her class, Google Classroom, for you all to watch if you'd rather watch that as well. Thank you so much for watching, guys.